Hi, my name is Kelly.
And my name is Anthony.
In today's video, we will be reviewing the topics covered by Arvin Ashe's Copenhagen versus the Multiworld interpretation of quantum mechanics video. This video relates to our class as it talks about Schrödinger's equation, the wave function, as well as its relation to probability.
We made a diorama to help represent and visualize the basics and the difference between the two concepts. For this diorama, we have created Hell's Quantum Kitchen in order to demonstrate what Arvin Ashe was able to properly explain about the Copenhagen and many world theories from his original video.
Using the diorama to demonstrate Copenhagen theory, we have Hell's Quantum Kitchen. There was an order made for a medium rare steak, and the chef has finished cooking the steak and has now walked it out. While the steak is uncut, similar to Schrödinger's cat experiment, it can be interpreted as both perfectly cooked at medium rare, yet also it can be perfectly done wrong and overcooked like a dry piece of leather. Therefore, we can say the steak is in a state of superposition where there is a certain probability for either outcome to occur. According to the Copenhagen theory, once a measurement or observation has been made, in this case the steak is cut in order to reveal the cook, the wave function collapses and observed result is the only outcome that exists. For example, in this scenario, the steak has been perfectly cooked to its specified order and Gordan Ramsey is pleased with the chef.
In the video, Arvin Ashe is able to properly explain the basics of quantum mechanics. This is shown in the following clip when he talks about superposition.
Primary challenge of understanding quantum mechanics is that according to the equations, all particles exist in a state of superposition. That is to say that the properties of any quantum particle, such as its position, momentum, spin, etc., is not only unknown, but is unknowable until it is measured. In fact, before it is measured, the particle is said to be in many states at once. It's not here or there, it is here and there at the same time. It's not spin up or spin down, it is spin up and spin down at the same time.
Although Arvin Ashe explains the basics of quantum mechanics, he also fails to go into extreme detail about the Copenhagen theorem. An example of this would be when he talks about the wave function collapsing once a measurement is made, and he goes on to say that this is the main reason as to why the physics community doesn't have a full consensus on for this theory. He also goes on without explaining what it means for a wave function to collapse or why it is detrimental to the theory seen in the following clip.
Bohr might have said, well, it's just the data. The data is that we observe only one event, so all the other events that we could have observed no longer exist. We are just interpreting quantum mechanics based on the data that we can plainly see. Don't ask me how or why this happens. Or you can say what Richard Feynman says when asked the question, just shut up and calculate.
This clip demonstrates a moment where Arvin Ashe expects the viewer to have a general knowledge of the theory before watching his video. Overall, Arvin Ashe's explanation of the Copenhagen theory is mostly an introduction to quantum mechanics, rather than one that discusses the in-depth success or problems of the Copenhagen theory. Therefore, this portion of the video would be one I recommend to someone who is trying to learn the basics of quantum mechanics in terms of superposition, and not someone who is trying to do an in-depth research about the Copenhagen theory. Now returning to Hell's Quantum Kitchen to quickly demonstrate the basics of the many worlds theory. In this scenario, an order for a medium rare steak is once again placed and prepared by the same chef. Just like in the previous example, the steak is also in a state of superposition, whether it is perfectly cooked or overcooked. However, unlike the Copenhagen example, the many worlds interpretation says that when Gordan Ramsey slices into the steak to determine its state, instead of the wave function collapsing, there is instead of a splitting of worlds, or in other words, a world where Gordan Ramsey gets a perfectly cooked steak, and a world where he gets an overcooked steak and proceeds to use one of his signature lines.
What are you? An idiot sandwich. Idiot sandwich what? An idiot sandwich, Chef Ramsey.
In Arvin Ashe's video, he had done an amazing job explaining the multi-world theory in comparison to the Copenhagen portion. In the video, he had used various animations and visuals to explain the multi-world interpretation and on the Schrödinger's cat experiment. And unlike his Copenhagen explanation, he spent the time to explain certain terminology. For example, he thoroughly explained quantum decoherence.
How does the split of the worlds occur? Everettians say that it's due to decoherence. So what the heck is decoherence? Quantum decoherence is the physical process that's used to describe how quantum states transition to the one state that we experience. The Copenhagen interpretation treats the wave function collapse as a fundamental process without explaining the details of how it happens. Decoherence attempts to explain what appears to be like wave function collapse, but in MWI speak, it is a splitting of worlds. No wave collapse actually occurs. If the universe was composed of just you and the cat and nothing else, then you and the cat would be in a coherent superposition. This would be represented by our original equation here. The key realization is that in reality, you have more than just you and the cat entangled. Both you and the cat will also be entangled with your environment because that is also a quantum system. So for example, the cat will be entangled with what's inside the box, atoms of air, photons of black body radiation, etc. All these objects will be entangled with the cat. And you will also be entangled with your environment. The environment inside the box for a cat that is alive will be different than the environment for a cat that is dead. Why? Because a dead cat's interaction with the air molecules and photons will be different. Not only because its position will likely be different, but also other factors such as heat produced, etc. So psi now looks like this, where there is an added component of the cat and you being entangled with environment 1 in one case and environment 2 in the other case. These two environments are completely different. Because the entanglement with the environment now enters the picture, the coherent superposition between you and the cat is broken. The Schrödinger equation says that the two parts of the wave function above are perpendicular to each other, that have no connection to each other. This can be interpreted as two separate worlds. It's as if the universe splits into two realities. This is decoherence. Decoherence is another way of explaining how quantum superposition gets lost by interaction with the environment. You can also think of this as the quantum nature of the original two-component system leaking information into the environment due to its entanglement with the environment.
However, a possible major negative of his video's explanation was there was a slight bias towards many worlds. This can be seen as he spent more time, more effort, and was able to use more detail for the many worlds theory in comparison to the Copenhagen theory. So, his advanced explanation of multi-world theory over Copenhagen's interpretation may cause a shift for the public audience believing that the multi-world theory is better because they would have more information on this topic from this video.
Overall, for the general public or beginner quantum learner, the concepts covered in Arvin Ashe's video would be difficult to digest since he uses some terms and vocabulary the common person does not know, and he does not always take the time to fully explain some of the concepts.
Arvin Ashe also included that the Copenhagen interpretation and the multi-world interpretation are not the only theories out there. In this following clip, he adds other interpretations.
Now, if the idea of quantum superposition and randomness makes you uncomfortable, I want you to relax because there are completely deterministic interpretations as well. One is the de Broglie-Bohm or pilot wave theory, also known as Bohmian mechanics. Another fascinating theory I like is the objective collapse theory by Roger Penrose, who combines principles from general relativity with quantum mechanics.
So although there are some negative points listed, Arvin Ashe's video does demonstrate a basis for the Copenhagen theory, which could be understood by anyone with intermediate knowledge in quantum mechanics. He is able to supply an in-depth look at the many worlds theory for those who are more interested in learning that theory or accepting that theory.
Tell me!
Go! He's gonna let us